And we're live, and we're doing this, and it's amazing. So in today's video we have some cool stuff going on. We're going to take a look at what's wrong with this servo setup here, and I just showed you kind of what we're going to install. Pretty simple. We'll talk specs, and we're going to whack this servo thing right in the face. First off, we're going to get this, let me see what I can do here. We're going to get this servo out. So that's the first thing to do today. Let me move all this stuff out of the way. We're going with a typical non-Servo Saver setup on this. I'm going to pull all this apart here. And we're going to go non-Servo Saver just because of the nature of where this project is at. We're trying to slow it down. If you guys are new to this build and haven't seen this before, I'll give you a quick intro on what's happening here. This is an Axial Ryft. Cool truck. Rock bouncer. It's super floppy and very difficult to drive, which is because rock bouncer. And we're going to change a bunch of stuff on it, like a lot of stuff. So one of the things we're going to do is get rid of this Servo Saver, which, and you'll see in my last couple videos, this thing is like really floppy. It has an interesting design. So there's an insert in there so that you can set your servo match right at 23, 24, 25 tooth. The stock Spectrum servos there are 23. So this has a 23 tooth insert. And then it's got a spring inside and a punch out here in the center so that the servo can swivel with the arm kind of on a spring. That's what a Servo Saver does. And the intent is that when this thing is bashing around in the rocks like this, that you're not actually stripping the teeth out of the servo. This servo, which is a 614S, this is the typical RTR servo from Spectrum. That is a 15 kg servo from the factory, and we're replacing it with a 25 kg all metal waterproof Power HD. This is, the model number on this one is LW25MG. You can get a little view of that right there on the bottom. LW25MG. So you can run this up to 8.4 volts. The good news for us is that we do have a programmable BEC on the ESC, which is a hobby wing axe. And so we can set the output on this a little bit higher from 6 volts to 7.4 say. And then we will get a little more kick in the servo pants. This is a pretty simple uninstall. It's all, the screws are all mounted in the front. I do like the axle design for the simplicity of the assembly actually. Pretty easy to deal with, you know. And they have, the plastic is really hard in the front, so it sounds like you're unscrewing these out of a lock nut. That's how tight they are in the screw holes. Can't beat that. The servo is not going to fall out. That should just slide right out. There we go. So now this servo works totally fine. But as a 15 kg with a giant tire and then a really sloppy Servo Saver, it's just not a situation that works well for me. So this thing is going to a different project. I don't know what yet, but something that has very low demand. And we're going to drop in this new Power HD. Won't be hard, I'll tell you that right now. Having an all metal case is kind of nice. You don't have to worry too much about stressing it out by slamming it in there with the screws. We're just going to power screw these right back in because it's aluminum and not going to hurt anything. Threads are already made. So, simple. So, that, why a Power HD instead of something else? Well, I actually already had one. I bought it a long time ago for a scale truck project. And I didn't use it yet, so it was still sitting there in the case. I have had a lot of good luck with the Power HD. They are fairly strong. This is how I would describe it. They're very strong for the dollar. Not a very expensive servo. Quite well made. Quite well made. I've had really good success with these. Now, what I am going to do, because I'm now getting rid of the 23 tooth Servo Saver, this thing, I'm going to replace it with a, with a Team K&K 25 tooth all brass servo horn. Why do I care if it's brass? I don't care if it's brass. I've never been one to promote, you know, using brass over aluminum, over steel horns, over whatever. But these things are all machined and they're essentially indestructible. They have a nice long servo length. And what I need to do is match up. I'm going to line these up so you can see this. I'm going to match up the servo hole. So that servo hole is lined up. And then you see that there's a screw mount right there in exactly the same length away from that. So that distance to here is exactly the same as my new servo horn from here to there. And this will not bend or whatever. So this is double shear because you don't want it to flex when it's trying to do its job. This thing is like, I don't know, 4 millimeters solid brass or something, and it's absolutely not going to bend. Okay, there's no reason why this will ever bend. So we're going to stick that on like that. I still have lots of room for this servo to swing around in there. You can see there's tons of room for this to fit. Loads of room. No problem there. I'm going to stick a screw in that and see if I can find a short M3 kicking around here somewhere. There's one. Maybe not. Maybe not. Okay, there we go. Sorry, I have a pile of screws over there and I had to find one that would fit. So, because the Servo Saver is so thick, you have to use a really long screw on it, and that's not thick anymore, so there's no more long screw, so I can just put a regular short M3 screw in there like this, and that should bottom right out in there. Now, that basically just holds it on. There's an actual side screw on the horn right here. So there's a separate screw that clamps the horn. It just squishes it together onto the, you can see how that's not quite tight. I'll turn this a bit. So this is not quite tight, and you can kind of wiggle it a little bit. I didn't tighten that yet, so you can kind of wiggle this around a little bit. Now I'm going to tighten the side screw, and I'll show you what happens when you do that. So I'm going to tighten down that side screw because it clamps onto the servo. So there's a slot all the way down the horn, and that slot right there actually allows the spline to pinch when you tighten that screw. So now let's check out the play. None. Zero play. That thing is completely stuck on there. It will never move. And now I can tighten down this top one to take up the rest of the slack in there. There we go. So that thing will never move. That is done forever. And we're going to put this push rod back on to that hole. I guess it would be the highest hole up, closest to the center line. Let me get a screw for that, and we'll put a new screw in there. You can see I need a different screw because the Servo Saver is a totally different setup than this. So we'll crank that on. Now this horn, you saw that earlier, it actually has a space in the back for a lock nut. If you happen to wreck these threads for some reason, you can put a nut inside, and that will basically guarantee it will never fall out. or bend or twist or anything. So now we've got absolutely locked in steering. Finally, no more sloppy steering. I'm so happy about that. So the Power HD fits right in the stock hole. New horn. We added some neat, interesting colors to it, and we've got the right amount of steering throw. I'm pretty sure that servo will have no problem looking after this load. I have no play in the front end. Look at that. To me, that would be considered no play. There's a little bit of play at the ball joint end right here, which you can see there a little tiny bit. There's a tiny bit of play right there, but that's it. There's no more play. I mean, the steering is now tight. That is going to be fixed forever. I'm so incredibly excited about that because I absolutely could not stand the sloppy steering on this vehicle. So, we're going to look at a little bit of electronic stuff today. We talked about the battery tray and stuff last week. Remove all this junk. Talked about the battery tray last week. You can see I've got my Helios 3000 3-cell in there. I'll pull that out and show you. So this is the battery. It's a 45C 3000 3S. And what I'm going to do is simply marry this up to the hobby wing, which already comes with an XT60. Done. I don't even have to change the ends. I love that. And Helios RC is really good at providing batteries with lots of different ends. So instead of having like an adapter plug, I've seen some of the places now where you buy a battery, it comes with some kind of a weird end, and then you have to put like an adapter on it to fit to Traxxas or Dean's or XT60 or whatever, EC3, EC5, TC7, Neon 9, whatever the plug adapter is. But the battery comes with a proprietary post kind of a adapter system on it. I'm not a fan. And I'm not a fan because, in my opinion, the least amount of connections you can have to transfer power, the better. So, Helios RC does a great job of providing batteries with lots of different ends already on it. So if I needed an XT60 connection, it was already on the speed control. Now it's already on the battery. I don't have to do anything. This just slides in here, and you can put it in right from the back, even if the wheels are all on and everything. There's so much room underneath, you could actually do it from the bottom, you know. So like that's what I'm intending to do with this, because I will have a pretty detailed interior in the way up top, so I can still get the battery in and plug it in and all that stuff from the bottom where it's kind of not visible. That's the goal. And that fits right in there. Try to give you a different view of that. You can see the battery inside there. So that's it. It just sits right there. Now, I have a whole bunch of electronics going into the cabin. Special like lights and gauges and weird stuff I'm doing. We'll talk about that on the next one. And what I have to do then is find places for stuff like this. I don't think I'm ever going to need to run the fan on this, so I'm seriously considering taking the fan off forever. Just because it's a little higher, it's a little more space that I don't want to give up. I have decided that this is going to go into this hole right here. So I'm going to put this in pretty much there. You can see it sitting there. There's kind of like a foot pan almost. If this was a real buggy, that would be where say the person on the left, their feet would sit right there. It's not, there's no wires in the way of the drive shaft. There's no wires in the way of anything at that point. And when you close this off with the panels on it, it'll cover that completely up so that you don't actually see it. I have room for the fan, but I don't think it's going to be necessary, so I may actually take it off. I don't know, maybe I'll wait to take it off, because I kind of don't want to have to listen to the fan. If this is one of those ESCs where the fan runs all the time, I think it's coming off. I'm not going to load the thing down enough to worry about the heat. It's got a nice open space for it to live. There's airflow here, I'm sure, so I'm going to leave it like that. Motor wires, I can bend around and solder them onto the ESC right there. So I'm sure I can tuck all that underneath the engine cover somehow. And that's where the ESC is going to live. And then what that means is when this battery connection comes to the back, I've got the wires all in a knot here. Excuse me for a second. So when that comes to the back, you can see already how easy that's going to be. There's the two connections right there. So I just have to tie this one up from the speed control so that when I plug in the battery, none of it's in the way of the drive shafts and the moving bits. And that's it. The wires are long, man. I mean, that is a long power wire for a speed control. I'm kind of happy that they come that way. They're really easy to change because they've got already the solder joints on it. Hang on a second. So there's already solder connection posts on the speed control, so if you have to take them off and put your own wire, that's fine. This is the fan plug. It's intended to go into like receiver power or something. So I don't believe it would have its own thermostat to switch inside the fan. So I think they assume the fan is just on. And I think I don't want that. There's my electronic setup for now. I'm really glad we got the servo in. The next thing I'm going to do is install the receiver. And the factory receiver is, of course, this Spectrum. And I'm going to reuse this for now. I'm not using the telemetry stuff on it. I don't need the AVC stuff on it, so I don't care which way that it's mounted. I think with the AVC receivers, you have to mount them in a certain direction or something so that you can actually get it to function properly when it's trying to help you out with the control. But I don't care about that. So this is very likely going to sit right beside the transfer case on the floor right there. I'm going to put it right there because it's down low. I got lots of room to put wires. The wires will sit directly in top like this. I can have a seat and a driver cover that completely, so that won't be seen at all. And if I should have to service it for some reason, I can take off the side panel and actually get into the wiring from the side panel. I mean, you can see it sitting right there. It's like right there. So I won't have any problem plugging or unplugging something if I had to, and leave the interior in the vehicle. So that's kind of the plan for that. And I'm going to get all those hooked up in short order, mount this, mount that, get the wiring tidied up for these two parts, and solder the motor on, and we'll have those done for the next video so you guys can see what that looks like. And then we're going to move to the next step of the scale out, which is going to be interior setup and such like that. So thanks for watching. That's where we're at with the progress, and I cannot wait for this thing to finally steer. I'm so excited. Talk to you on the next one.